Hello everyone, hope you all are fine. Dear students, today we will learn about new topic, that is common factors and common multiples. Okay. Dear students, you observe the factors of some numbers taken in pairs. Okay. I'll take the number 4 and 18. Okay. Now we will find out the factors of 4 and 18. Firstly, the number 4. 1 4 is 4. 2 2 is 4. Yes, the factors of 4 are 1, 2 and 4. Got it? Now we will find the factors of the number 18. Okay. 18 1 ja 18. 2 9 ja 18. 3 6 ja 18. Yes, the factors of 18 are 1, 2, 3, 6, 9, 18. Then what is the common factor? How do we find out the common factors? Dear children, when we find the factors of 2 or more numbers and then find some factors are the same, means common, then they are the common factors. Okay. Then children, which is the common factor? Tell me. Yes, the numbers 1 and 2 are the common factors of both 4 and 18. Got it? Dear children, let us now, we will find out the common multiples of 4 and 6. Okay. Firstly, the multiples of 4 are 4, 8, 12, 16, 20, 24, so on. Yes. Then the multiples of 6 are 6, 12, 18, 24, 30, 36, so on. Dear children, here we can observe that 12, 24, 36 are multiples of both 4 and 6. Yes, they are called the common multiples of 4 and 6. Have you understood?
Some more divisibility rules. Students, in the previous sessions, we have learnt about the divisibility rules for 2, 3, 4, 5, 6, 8, 9, 10, and 11. Let us now learn some more divisibility rules. For this, consider the composite numbers, say, 12 and 28. We know that 12 is divisible by 6. Now factors of 6 are 1, 2, 3, and 6. Using the known divisibility rules, we can say that 1, 2, 3, and 6 also divide 12. Our next number is 28. 14 is one of its factors. Factors of 14 are 1, 2, 7, and 14, by which 28 is also divisible. From these observations, we can say that if a number is divisible by another number, then it is divisible by each of the factors of that number. Now let us find the next rule by considering the numbers 24 and 72. 24 is divisible by both 4 and 3, which are coprime. It is also divisible by their product, 12, 72 also follows the same pattern, that is, it is divisible by 2, as well as 9, which are coprimes. 72 is also divisible by 2 multiplied by 9, that is, 18. From this, we conclude that, if a number is divisible by 2 coprime numbers, then it is divisible by their product also. For finding some more rules, consider these pairs. Observe that the numbers in each pair have 5 and 3, respectively, as their common factors. Now adding both the pairs individually, we get 45 and 30, which are also divisible by 5 and 3, respectively. So, we can say that, if two given numbers are divisible by a number, then their sum is also divisible by that number. Let us see whether it is true for subtraction also. For this, we subtract the numbers in each of these pairs to get 5 and 12. Observe that the remainders are also divisible by 5 and 3. Hence, we can say that, if two given numbers are divisible by a number, then their difference is also divisible by that number.
Prime factorization. What is prime factorization? Prime factorization is finding which prime numbers multiply together to make the original number. We first refresh our memory on prime numbers. Prime numbers are whole numbers greater than 1 that have only two factors, 1 and the number itself. For example, 2, 3, 5, 7 and 11 are the first few prime numbers. Now the question is, what are the two methods of prime factorization? Prime factorization is performed in two ways. First, factor tree method. Second is upside down division. First, we will discuss factor tree method. A factor tree is a diagram used to determine the prime factors of a natural number greater than 1. We often use factor trees as a method to perform prime factorization. Let's look at an example using the number 70. Think about factors that will give us a product of 70. 70 is even. We know it is divisible by 2. 2 into 35 will give us 70. Here, 2 is a prime, but 35 is not. So we have to keep going. What factors will give us a product of 35? 5 into 7 is equal to 35. So let's break that down once more. The numbers we are left with cannot be broken down any further. Now that we only have prime numbers left, we can find the prime factorization of 70. The prime factorization of 70 is 2 into 5 into 7. But how do we know this is correct? You can always check your work in maths. Simply multiply your factors to be sure that they result in your original value. 2 into 5 is 10, 10 into 7 is 70. So, good job. The prime factorization is correct. Let's try one more factor tree using two different factors that gives us 70. When we multiply 7 into 10, we still get 70. 7 is a prime number. But what about 10? 5 into 2 is equal to 10. So let's break that down once more. Now the number cannot be broken down any further. Be confident that no matter which factor you start with, if you keep going until there are only prime factors left, you will get the right answer. Keep in mind, it is proper math etiquette to write your answer with the prime values in order from least to greatest. So the prime factorization of 70 is 2 into 5 into 7. Let's take one example. Prime factorization of 30 using factor tree method. 30 is equal to 5 into 6. 5 is a prime number. What about 6? 6 is equal to 2 into 3. Now the numbers cannot be broken down any further. Therefore, the prime factorization of 30 is equal to 2 into 3 into 5. Next method of prime factorization is upside down division. In this method, you will divide a number evenly by the smallest prime number you can. It is called the upside down division because the division symbol is flipped upside down. Example, prime factorization of 6. We will start the prime factorization of 6 with the smallest prime number 2. 6 is an even number. So when we divide 6 by 2, we'll get 3. 3 is a prime number. So 3 divided by 3 is 1. Therefore, the prime factorization of 6 is equal to 2 into 3. Let's do prime factorization of 80 using upside down division method. 80 is an even number. So we will start with the smallest prime number 2. 80 divided by 2 gives us 40. 40 is again an even number. So 40 divided by 2 we will get 20. 20 is again an even number. So divisible by 2. 20 divided by 2 we will get 10. 10 is again an even number. So when we divide 10 by 2 we'll get 5. 5 is a prime number. So 5 divided by 5 is 1. Therefore, the prime factorization of 80 is equal to 2 into 2 into 2 into 2 4 times into 5. One more example, prime factorization of 24 using both the methods. Factor tree method, upside down division method. Let's have a look. I hope topic prime factorization is clear to all of you.
Learn about the highest common factor, also called HCF. We have already studied factors. Now let us understand the meaning of the term common factor. If two or more numbers have the same numbers as their factors, those factors are called common factors. Now let us see what do we mean by the highest common factor. To understand it in a better way, let us solve an example. Find the HCF of 15 and 25. We will follow a three-step process to find the highest common factor. Step 1. Find all the factors of the given numbers. Here, the pairs of factors of number 15 are 1 into 15 is equal to 15. 3 into 5 is equal to 15. Thus, the factors of 15 are 1, 3, 5 and 15. Next are the pairs of factors of the number 25. 1 into 25 is equal to 25. 5 into 5 is equal to 25. Thus, the factors of 25 are 1, 5 and 25. Step 2. Identify the common factors of the given numbers. Here, the common factors of numbers 15 and 25 are 1, 5. Step 3. The largest of the common factors is the HCF of the given numbers. Here, the largest of the common factors is 5. Thus, the highest common factor is 5. Hence, we define the highest common factor as the largest common factor that two or more numbers have. Now, let us solve one more example. Find the HCF of 6, 12 and 18. Here, the pairs of factors of number 6 are 1 into 6 is equal to 6. 2 into 3 is equal to 6. Thus, the factors of 6 are 1, 2, 3 and 6. The pairs of factors of the number 12 are 1 into 12 is equal to 12. 2 into 6 is equal to 12. 3 into 4 is equal to 12. Thus, the factors of 12 are 1, 2, 3, 4, 6 and 12. The pairs of factors of the number 18 are 1 into 18 is equal to 18. 2 into 9 is equal to 18. 3 into 6 is equal to 18. Thus, the factors of 18 are 1, 2, 3, 6, 9 and 18. Here, the common factors of numbers 6, 12 and 18 are 1, 2, 3 and 6. Here, the largest of the common factor is 6. Thus, HCF is 6. Did you notice that one particular number is a common factor for all the numbers? Do you know which number is that? Yes, 1 is a common factor of all the numbers. Wasn't it easy finding the highest common factor or HCF? Today we will learn how to find HCF by prime factorization method. Find the HCF of 32 and 24. Step 1. Find the prime factors of the given numbers. First, find the prime factors of 32. Begin with the smallest prime number, 2. Dividing 32 by 2, we get 16. On dividing 16 by 2, we get 8. Again, we divide 8 by 2 to get 4. And 4 divided by 2 gives 2. As 2 is a prime number, we divide it by itself and get 1 as the quotient. Thus, the prime factorization of 32 is 2 into 2 into 2 into 2 into 2. Now, find the prime factors of 24. Dividing 24 by 2, we get 12. Now divide 12 by 2 to get 6. Divide 6 by 2 to get 3. 3 is a prime number, so we divide it by itself and get 1 as a quotient. Thus, the prime factorization of 24 is 2 into 2 into 2 into 3. Step 2. Circle the common prime factors of the given numbers. Here, the common factors are 2, 2 and 2. Step 3. The product of the common prime factors of the numbers gives the HCF. Thus, the HCF of 32 and 24 is equal to 2 into 2 into 2 is equal to 8. Let us take another example. Find the HCF of 44, 77 and 110. First, we find the prime factorization of all these numbers individually. We get the prime factorization of 44 as 2 into 2 into 11, 77 as 7 into 11 and 110 as 2 into 5 into 11. Next, circle the common prime factors of 44, 77 and 110. Here, the common factor is only 11. Since there is only one common factor here, the HCF of these numbers is also the same, that is 11.
Lowest common multiple. Let's find the multiples of 6 and 8. The multiples of 6 are 6, 12, 18, 24, 30, 36, 42, 48 and so on. And multiples of 8 are 8, 16, 24, 32, 40, 48, 56, 64 and so on. The multiples 24 and 48 are common to both numbers. That is, these are divisible by both 6 and 8. Of these multiples, 24 is the lowest number which is divisible by both 6 and 8. So, 24 is the LCM of given numbers. We can also say that the lowest of all common multiples of given numbers is called the lowest common multiple or LCM. Or it is also defined as the lowest number that is divisible by each of the given numbers. It is also called smallest common multiple or least common multiple. Let's learn how to find LCM of given numbers. One way to do so is to list down all the multiples of both numbers and find the least number that is common to all given numbers. But finding all multiples is time consuming and difficult as well. So we use prime factorization method. The prime factorization of 6 can be done like this. We find a prime number that can divide the given number and then write the prime number to the left of given number and quotient of division below given number. We do this several times to find the prime factors of given number. Here prime factors of 6 are 2 and 3. Similarly, we can find prime factors of 8 as 2, 2 and 2. Let's find LCM of 6 and 8. Consider each prime factor and count their occurrences in factors of each number. In the factors of 6, the prime factor 2 occurs once, but in the factors of 8, it occurs 3 times. Write the product of maximum occurrences. 2 multiplied by 2 multiplied by 2. Find the next prime factor and count its occurrences.
3 occur only once in 6. So include 3 in the product 2 multiplied by 2 multiplied by 2 multiplied by 3. The product of these factors is 24 and it is the LCM of two numbers. We can also find LCM using another method called common division method. Let's write the numbers in a row, keeping them separated. Select a least prime number that can divide at least one of these numbers. Here it is 2. At least means minimum one number must be divided. It is well and good if more than one numbers are divided. Let's divide 6 and 8 by 2 and write their quotients 3 and 4 respectively in the next row. Again find the least prime number that can divide at least one of these numbers. Here it is 2. 3 cannot be divided, so carry it as it is to the next row. 4 divided by 2 is 2, so write 2 in the next row. Again 2 can be divided by 2, so write quotient of the division, that is 1, to next row. Also carry 3 to next row again. Now this row contains 3 and 1. We will take 3 as the next prime number as it can divide it. The quotient of division 1 is written in next row. Also 1 is carried to the next row. Here we stop as we got all ones in the row. The product of these numbers give us the LCM. So LCM is 2 multiplied by 2 multiplied by 2 multiplied by 3, which is equals to 24. Let's take an example. Find the LCM of 24, 28 and 36. We will find the answer with both methods. Prime factors of 24 can be found like this. So 24 is equals to 2 multiplied by 2 multiplied by 2 multiplied by 3. Prime factors of 28 can be found like this. So 28 equals to 2 multiplied by 2 multiplied by 7. Prime factors of 36 can be found like this. So 36 is equals to 2 multiplied by 2 multiplied by 3 multiplied by 3. Let's consider each prime factor and count their occurrences in factors of each number. 2 occurred 3 times in 24, 2 times in 28 and 2 times in 36. So select maximum occurrences 2 multiplied by 2 multiplied by 2. 3 occurred 1 time in 24 and 2 times in 36. So select maximum occurrences of 3. 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3. 7 occurred 1 time in 28. So select this occurrence as well. The product gives number 504. Let's find LCM by second method. Write the numbers in row separated by some space as shown in the screen. Find smallest prime number that can divide at least one of the numbers. Since all numbers are even number, so 2 can divide all of them. So let's write 2 here. 24 divided by 2 is 12. 28 divided by 2 is 14. And 36 divided by 2 is 18. Again we can divide them by 2. So let's write 2 here. Quotients of division will be 6, 7 and 9. Again divide by 2. Write quotient 3. Carry 7 and 9 to next row since these are not divisible by 2. Now, as there is no number which can be divided by 2, so take next prime number 3. As 3 can divide 3 and 9, so let's write it here and quotients of division 1 and 3 in next row. Also carry 7 to next row. We can use prime number 3 again to divide 3. So quotient is 1. Carry 1 and 7 also to next row. Next prime number that can divide any one of them is 7. Write quotient 1 here and also carry other ones to next row as well. Now we have all ones in the last row, so we will stop here. LCM is product of all these numbers. So LCM is equals to 504. So I hope you understood the explained topic very well.